In this video, I will demonstrate how to compute double integrals using Python. By the end of this video, we're going to compute the integral y equals 0 to 2, and then the integral from x equals 0 to x equals 1 of x divided by 4 minus 3y dx dy. Now, in order to do this, we're going to utilize a package called sympy, S-Y-M-P-Y. It basically lets us use Python to establish symbols, which we will then use to integrate. So the first thing you need to do is install the package. So on your command prompt, PowerShell, whatever you're going to use to compile your programs, we need to run pip install sympy. Mine is already installed, so it didn't take any time. The first time you run it, it may take a couple of minutes. So run that, and I will see you at your favorite visual IDE. I'm going to use VS Code. Okay, I'm on VS Code. Let's make a new file. I'm going to call it integrals.py. And just throw my name at the top. I'll include the source code in the description too. Let's just start by kind of defining what all we want to do in this file. So we want to evaluate a double integral, right? And there's going to be some parameters. Let's explain what those will be. First parameter we're going to pass, oh my goodness, is an integrand. This will be a sympy sympy expression. And this will be, of course, the actual function we want to integrate. We'll have two variables, right? So we're going to do var1, and this will also be a sympy symbol. If you want to look up more about how sympy actually works, there are plenty of articles. I'm just going to demonstrate the double integral function. So this will be the first value, or the first variable, excuse me, that we want to integrate. Then we'll have var1, we'll say bounds. And I'm just going to make this a tuple because we know it's just going to be two values. This will be the limits for the first variable. And it will be the lower bound first, followed by the upper. And then we're just going to repeat this for the last two parameters, except of course it'll be var2 bounds, and then instead of first variable, this will be the second variable. Okay, and then we're going to return just one value, basically. We're going to return a sympy expression. It will be the evaluated double integral. Okay, let's get started. First, we need to import sympy to this actual file. So we're going to import sympy as pi. And let's just make an example. Right, so you can make a function, of course, where you actually pass variables in, but I'm just, for this video, just going to show its functionality. So as I showed, we're going to define x and y equal to, we're going to use sp because that is the spec that I declared here for sympy. Sp, we're going to use the symbols class. And we're just going to essentially retype in those parameters so that it can pass through sympy. Now you're going to use those same symbols to define your integrand. So as I said in the beginning of the video, we're going to do x divided by 4 minus 3 times y. Okay, now let's do our upper bound, or sorry, our bounds for the first variable. So this is a tuple, right? So we're going to use parentheses, and we're going to go from 0 to 1 for our x. Then for variable 2 bounds, another tuple. We're going to go from 0 to 2. And then we'll just define the result as, we're going to do evaluate underscore double underscore integral. Be able to passing the integrand, x variable, var1 underscore limits. We're going to do the second variable, var2. I don't know why I wrote limits. I've been doing bounds. var1 bounds. Okay. So of course I need to actually define my function up here. So what all am I passing? So we're passing the integrand, we're passing our first variable, we're passing the bounds of the first variable, then we're passing the second variable, followed by the bounds of the last variable. Okay. And then we'll just print out our result. Yeah. We'll do I'll show you how to actually do the integration last, but we're just going to print, printf. We'll say the result of the double integral is, we'll make it a variable, we'll call it result. How about that? Okay. So in order to actually compute the integration, what we're going to do is we'll make integral be the variable, and we'll say it's equal to sp.integrate. So this is what's actually going to compute the integration. First, we need to pass our integrand, and then we're going to make a parenthesis. We have to make it kind of like a tuple. So first we'll pass the variable, then we'll pass the lower bound, limits, so that would be at 0. Why do I keep writing limit? Bounds. There we go. var1 bounds at 1. That'll get us the upper bound. Okay. And now let's do the second variable. So we have var2. var2 bounds at 0. var2 bounds at 1 to get the upper bound. And then we'll just return the integral. Awesome. And of course, let me make sure I indent this all properly. And that should take care of the entire program. So let's go ahead and test out running it. Go save it, and I'll see you at the console. Okay, so I ran this on Wolfram Alpha, and we should get -23 divided by 4 for our answer. So let's open the command line again, and then I just navigate to my program. So I put it in downloads, and I put it in a folder called Py. And use Python to run it. So Python integral.py. And the runtime is kind of all over the place, to be honest. This time it took longer. Sometimes it doesn't take as long, but here we go. The result is -23 divided by 4. So I will include my source code in the description of this video if you want to copy and paste it for yourself and do whatever you want. It would probably be useful to make a function where the user can just pass in their variables and whatnot, but hopefully this helps get you started. Thanks for watching.